Good day, I'm Vanessa Candelaria and I'm here to discuss about the continuity at a number. The purpose of this video is to share our knowledge to our audience and to help them understand the topic more. At the end of this video, you can determine whether a number is continuous or discontinuous at a certain point. There are three conditions to be met to determine whether a number is continuous or not. First, if f of c exists. Second, if limit of f of x exists. And the third one is if f of c and the limit of f of x is equal. Here are the examples. This is an example of a graph that is continuous. A function is said to be continuous if there's no break, hole, or interruption in its graph. Unlike this one, we can see that there's a gap between this, and also this. Our first problem is f of x is equal to x squared plus 3x and x is equal to 1. First condition is f of c, which is 1, substitute 1, is equal to 4. f of c is equal to 4. Second condition, the limit of f of x as x approaches 1. Substituting 1 is a shortcut to get the limit, which is also 4. Third condition. As you can see, f of c is equal to the limit of f of x as x approaches 1, so third condition is met. Therefore, f is continuous at x is equal to 1. For our second example, f of x is equal to x plus 2 all over x squared minus 16 and x is equal to 4. First condition is f of 4, substitute, (6 over 16 minus 6 is equal to 6 over 0, which is undefined. So f of 4 does not exist. We can say that this function is discontinuous, but let's try the second condition. The limit of f of x as x approaches 4, substitute it is also undefined, so the limit does not exist. The function f of 4 is not equal to the limit of f of x as x approaches 4. Therefore, f is discontinuous at x is equal to 4.
Hi! Here's the summary of what Vanessa discussed. My name is Balaoro and join me for the digital continuation using PowerPoint. Continuity of the number. A function f of x is said to be continuous at x is equal to c if three conditions are passed. Number 1, f of c exists. Number 2, if the limit of f of x as x approaches c exists. Number 3, if the limit of f of x as x approaches c is equal to f of c. F of x is equal to 1 over x at x is equal to 2 is the given. Let's see. Number 1, f of 2 will give us 1/2. Number 2, limit of f of x as x approaches 2 will give us 1/2. Number 3, f of 2 is equal to the limit of f of x as x approaches 2. This gives a continuity. Looking at the graph, x is equal to 2, and the function f of x is equal to 1 over x is the blue dot. It is part of the continuity. Therefore, f of x is equal to 1 over x is continuous at x is equal to 2. Here are 4 points to be remembered when finding if a function is continuous at a number. If one of the 3 conditions is not met, then the function is not continuous at the certain number. A function is said to be continuous if there is no break or hole on its graph. Polynomial functions are continuous everywhere. Rational functions are continuous in their respective domains. Bottom line. A function is continuous at a number if the function exists at certain x is equal to c, and the limit of the function as x approaches c also exists, and both of them are equal with each other. You're going to need a pen and a paper to answer the following. 30 seconds for every item would be given to you. Okay, you try. Once the given is displayed in the slide, 30 seconds starts. But if you're not done yet, you can always pause the video. For number 1, time is up. How? Number 1, f of 2 is equal to negative 1. Number 2, limit of f of x as x approaches 2 will be equal to negative 1. Number 3, f of 2 is equal to the limit of f of x as x approaches 2. This shows continuity. But let's see the graph. And x is equal to 2 is the blue dot. Therefore, the function is continuous at x is equal to 2. So the answer is yes, it is continuous. Number 2. How? Number 1, f of 1 will give 1. Number 2, limit of f of x as x approaches 1 does not exist. Number 3, f of 1 is not equal to the limit of f of x as x approaches 1. As seen on the graph of the piecewise function, there's an open interval there and a closed interval there. There is a break. So therefore, it shows discontinuity. Therefore, the function is discontinuous at x is equal to 1. The answer is no, it is not continuous. So that would be all And thank you. Graphs from Mathway. Presentation made in PowerPoint.